Hey folks, Mr. Brayo here. So we're going to take a look at section 7.3, number 49. And this one's even more convoluted because we're starting with fractions. And I have a couple of options. I'm going to look at this through the elimination side of things because I have a 6 over x squared and a 1 over x squared. So I could multiply this bottom equation by -6 to get the same coefficient on the numerator, but opposite in signs. I also, if I look at the y squareds, if I wanted to eliminate them, I could multiply this equation by -6, because then I would also have the same number on the numerator, just opposite in signs. They'd both have 6's, just one would be positive and one would be negative. I'm going to just opt to get rid of the x's. So let me clear all of this out, and I'll just go with that first option. So what I'm going to do, and I'll change pen color here, is I'm going to multiply this entire equation by -6. I'm going to distribute that to all three terms here. And then I'm going to add my two equations together so I can eliminate the x squareds. So if you look at this next step here, right, that equation just the same as my first equation that I wrote up here, but this second equation now has that -6 distributed to it. So take a look, that first numerator is 1 times -6, right? The second numerator is now positive 66 because, oh, and actually that's a typo on my end. I'm going to fix it in the answer key, but really this should be 36. So let me go ahead and erase this, and let me write over it just so we're seeing it. So this, oops, let's get the pen. Right, this should actually be the number 36. So I apologize. I will take a note to myself and fix that. And then -6 times 1 is -6. Okay, so with all of that, let me just carefully erase some of my scratches here. When I go to add these terms together, these eliminate by design, and then -1 over y squared plus 36 over y squared is 35 over y squared. So I did get that one right. And if we think about 8 minus 6 over 8, right, if you want to think about where that comes from, well, I'm going to rewrite, this is going to be 8. If I simplify 6 over 8, that's going to be 3/4. So 8 can be written as 32/4, right, minus 3/4. Once I have those common denominators, I keep the 4, and I've got this 29 here, okay? And so then I'm going to cross multiply, and that'll get me this quadratic equation with a y squared. And you have a couple options, right? And when I say quadratic equation, I'm talking about that one here. I could set it equal to 0 and use the quadratic formula. I could factor if I wanted to, although I don't think this would factor. But because there's no linear term, right? It's just, I've got a quadratic term here with the y squared, and I've got a constant. There's no linear term. I can just solve for y squared. And I'm going to divide both sides by 29 for that, right? And then I want to square root both sides. And don't forget that lovely plus or minus shows up. And you can, if this works better for your brain, you can keep your y's here, or you can go ahead and take the 2 out, because if I think about 140 and I break it down, right, 14 times 10, this is going to be 2/7, this is going to be 2/5. So I can see there's a pair of 2's that would come out of the radical, and then that would leave me with 35 under the radical. And then if you wanted to even go further and rationalize the denominator, you can. You can take this as far as you want it. I'm going to leave it in one of these two forms. But once I have that, then I'm going to go ahead and substitute that. Let me scooch up. I'm going to substitute, just so we're clear, this expression or this one, depending on what you prefer. I'm going to substitute that back in for y squared on either one of my equations, up to you. First equation or second equation, and then solve for x. So as we scroll down, let me go ahead and just write that in this case, y is going to equal, I've got the plus or minus square root of 140 over 29, or again, you could use this version. And I'm just going to opt to plug it back into this equation. So I'm going to plug in y squared. And again, if I want to do y squared, that would be 140 over 29, right? So if I'm going to plug that in for y squared here, and it happens to be on the denominator, right, 1 over y squared. If I want to think about 1 over y squared, that would be the reciprocal, 29 over 140, and that's where you see me coming up with that number. And then I've got to go ahead with this. This is a quadratic equation with x squared. So I'm going to isolate the x squareds. I'm going to subtract the 29 over 140 from 8, right? So if I move this over here, 29 over 140, you're just going to have to trust me. It shows up as 1,049 over 140. Then I'm going to cross multiply these, right? And now we're at this quadratic equation with x squared. Again, I could set it equal to 0 and try and factor it. I could set it equal to 0 and use a quadratic formula. I'm actually just going to divide both sides by 1,049 because I don't have a linear term. I only have the quadratic term and the constant. So I'm just going to solve for x squared and then square root both sides. And again, you can leave this as square root of 280 over 383 once you reduce it, or you could take that 4 that's under the radical and move it out as a 2. Totally your call. But then here are my 2 y coordinates and here are all my 2 x coordinates. And I need each possible y to pair up with each possible x. So that's ultimately going to give me 4 ordered pairs, and you see them here, right? Positive 2 root 70s over 383, positive y coordinate, right? And then I have another positive x coordinate with a negative y coordinate. And then I have the negative x coordinate with a positive y coordinate and the negative with the negative. Those are the exact values. They're a little ugly, but we got them. Okay, thanks so much. Bye.